More important topic, which is linked list. So what is a linked list? So linked list is the data structure which store the element of the next element. For example, if you are making a linked list 1, 2, 3, 4 and 5. So 1 is storing the element address of 2, 2 is storing the address of 3, 3 is storing the address of 4, 4 is storing the address of 5. And 5 is not pointing to any other element, so it is storing null at the end. It is a singly linked list in which there is only one next pointer. If we are going to talk about the doubly linked list, so it will be pointing to previous as well as next. So we will talk about doubly linked list in the next video, which I am going to make it. So first of all we will initialize the linked list. How we are initializing the linked list? So first we will use a class list node in which we are using two specifier, public, and then in that we are using int data, and then list node star next. Now we are making a constructor in this, which is a parameterized constructor int data, and then this ka data is pointing to data, and this ka next is pointing to next. This ka next is pointing to null. Now we are making the linked list, which is this. See, this is the very basic step of creating the linked list. Even in the tree, even in the graph, not in graph, in linked list, in stack, in queue, you are creating the class first and then you are initializing it. We will talk one by one about all the data structures. So I started with linked list, then we will go to stack, queue and all that. So this is the first, which is linked list. So we created the class, and then now we are initializing the class, and we are creating the object for that. In this we are making the object name as root. This nodes are root equals to new list node of, let's say, 4. Okay, now root ka next equals to new list node of 5. Again root ka next equals to new list node of 6. Now we will display root. What is display root? In this I am making a function which is displaying all the elements in the linked list which is present. So list node star root. Now we are initializing one more linked list which is pointing to the root. Why we are doing like that, I will tell you. We are making a temp which is pointing to the root. So while temp is not equals to null, because see, I will tell first, I will write the code and I will tell why we are doing like this. See out temp ka val, and then temp equals to temp ka next. So why we are initializing the temp to the root? Because see, if we are initializing if we are adding any other element after this display root, and then we are making root ka next equals to new list node of 7 or 8 or whatever the element or the value which we are giving, we can't add because the root become null. Okay, so we can't make it, and here it will be cout temp ka data, because we are using data, not val, and then we are giving the space, so that's why we are using the inverted commas. So let's run it, and wait. Okay, I just see, you should name the same as what you are using the class name. So that's why it's showing list node. It should be the same as the class name, so that's why it's listonodi. All the things should be in the same what you are writing in the constructor. So see, now it is showing 4, 5, 6. Now we are displaying the elements. Now what we will do, we will if we have to add an element at the end. See, after this display root, again we have to, means I have to add one element at the end of the linked list. So what can I do? Insert, then root, then let's say 8. We are inserting element 8. Now again we will display root. Okay, so I will make a linked list node star insert, then list node star root comma int val, which is the value which we have to insert here. Okay, again we will initialize the list node start temp, which is pointing to the root. Now while temp is not equals to null, because we have to temp connects, we have to do dot temp. I will tell you why we are doing temp connects, not temp. Temp equals to temp next. Now here we will do temp next equals to new list node of val. Now here we will search return root. Why we are doing this, why we are not using temp is not equals to null, because if we will use temp is not equals to null, it will point after 6. Okay, but now if it will point to null after the 6, we can't insert the element at the null, right? Now we have to insert the element after 6, so that's why we are doing while temp next is not equals to null. So we have to go one element before the null element, so that's why we are going temp next is not equals to null. So how it will check? See, 4 it will check 5 is not null, so it will go to the 5, then 5 will check 6 is not null, so it will go till 6. Now 6 will check because 6 next is null, so it will stop at 6. Now we will insert the element after 6. So if we will run it, it will be sorry, I made display here. Yeah, it is wrong, no spelling, display. Now if I will run it, it will be 4 5 6. Okay, I will remove this because it will be confusing for you all. So it will show 4 5 6 8. Now we are inserting the element at the end. So in the next video I will tell how to insert in between and after the given node, before the given node, and all the specific conditions which are there. Then we will solve the deletion. Then we will go to some important questions which can come in linked list. Thank you for watching my channel, and please subscribe to my channel.